Alright, today we're going to look at using square roots to solve quadratics. So first I want to review square numbers. Square numbers have repeated factors. They're the product you get from repeated factors. So 1 times 1 is 1, 2 times 2 gives you 4, 4 is the square number, 3 times 3 is 9, 9 is the square number. And I always encourage all my students to have at least the first 15 square numbers memorized. The further you go and have memorized, just like the multiplication facts, will make your life a lot easier in your math class. So square numbers, your first 15 are listed here. Okay, and so for this lesson we also need to review perfect square trinomials. So you probably didn't see those last year in geometry very much, but they do show up a lot in Algebra 1. That's where you first were taught. Perfect square trinomials are the product when we have a binomial squared, okay? And what happens is our first and our last terms end up being squared. And that's going to be what we're looking for as we work with completing the square later on, is we're looking for those squares. All these numbers up here, the first term squared and the last term squared. Okay, so we're going to practice some examples of factoring perfect square trinomials, where we're going to take them from this standard form back to this form where it's the a minus b squared inside the parentheses. And be mindful of our signs as we're working them out, and you'll see I have a combination of where we see our middle terms being positive and what happens when our middle terms are negative. Okay, so the first thing is we must recognize perfect square trinomials. So we're looking at the first and the last terms to determine, are they square numbers? Well, x squared is a perfect square. Let me see if I can talk today. And then 49 is a perfect square as well. So therefore, I am going to take the square root of the first and the last term. And how we rewrite that is we end up with x plus 7, the square root of the first and the square root of the last, and we square that binomial. And if we factored this out and we did the FOIL method, or over, under, after we expanded it, we would get back to this answer above. Okay? And so the next example, checking to see if it's a perfect square trinomial. So is 4 perfect square? Yes. X squared is perfect square, and our last term 9. So I'll take the square root of the first and the last terms, and I get 2x plus 3, the square root of 9. So I took the square root of 4 and the square root of x squared and the square root of 9. That middle term disappears, as we've seen in the past. Okay, when we were doing the complex conjugate, we noticed that that middle term always canceled, so we were able to just multiply the first and last terms, right? Okay. Next, is it a perfect square? The first term, yes. X squared is a square. And 64, that is a square number as well. Perfect square trinomial. You'll notice our middle term is now a negative. So what that changes is now in my binomial, I will have a minus sign. Okay, so that sign comes down. Our last example here, is it a perfect square trinomial? Well, we have 9x squared. 9 is a square number, x squared is a perfect square, and 1 is a perfect square, because 1 times 1 is 1. It has that repeated factor. When I take the square root of the first, I get 3x, bring down that negative as a minus sign, and square root of 1 is 1. There you go, factoring perfect square trinomials.